What is machine learning? In simple words, machine learning is a process of training a machine or computer with huge amount of data so that it identifies the patterns and predicts the output. Let's take a simple example to understand this better. Imagine you want to build a system that can predict type of a flower. You will provide the system with 4 input parameters. Let's say length of a petal, width of the petal, length of the sepal, width of the sepal. Using these parameters, your system should predict type of a flower. Now in general programming world, if you put machine learning aside, you will start with identifying a programming language and you will write multiple if-else conditions. For example, if length of the petal is 4, width of the sepal is 6, call it as rose flower. You might write another if-else condition. If width of the petal is 6, length of the sepal is 2, call it as jasmine. Now the problem with this approach is that you will end up writing endless if-else conditions because there are multiple flowers, and even if you take rose as a flower, 2 roses are not the same. Some roses are small, some roses are big. So your if-else conditions will go out of your control. And even after writing multiple if-else conditions, if user gives inputs that are not handled in your if-else condition, your program will error out. In these cases, machine learning can help you. How? In machine learning, data scientist identifies a data set or huge amount of data. Fortunately today, data sets are available on the internet for free, a lot of them. And then the data scientist identifies an algorithm according to your requirement. Now, it is the responsibility of the data scientist to train the algorithm with the data set. During the training process, this algorithm will start identifying some patterns that you might not see as a human. And it starts developing a mathematical function. And this mathematical function is what we call as a model. So model is output of the machine learning process. Now this model is capable of predicting. Now let's say user gives input as 2 as petal length, 3 as petal width, 2 as sepal width, and 3 as sepal width. Taking this input, model can predict type of a flower. Now, it all depends on the efficiency of the algorithm and efficiency of the data set. If they are more efficient, the prediction of the model is also more efficient. End of the day, model is basically output of the machine learning process. A lot of people assume model as data, model as algorithm, but what is model? Model is basically a mathematical function. So finally, in machine learning, you don't have to write a lot of these if-else conditions, but algorithm is trained on the data set and it starts identifying the patterns and builds a mathematical function using which it can predict the output. This is about machine learning and models. Now let's understand how data scientists create a model. Imagine an organization wants to build a system that can predict type of a flower. The data scientists within the organization start with, so the step 1 is to start with a small data set or start with a data set. What is a data set? Data set is usually data that has the information of different features of a flower and what kind of flower it is. For example, data set has input features such as 4, 3, 5, 6 rows. Now, what does this mean? This is the petal length, this is the petal width, sepal width, and the output value. Similarly, 5, 4, 2, 3, Jasmine. So this way, dataset has multiple entries with features and then the actual output value. Now, once they have this data set with huge amount of data, as I told you, these days you can find a lot of free data sets on the internet. That's the good point. So data scientists collect that data set, and step 2 is they split the data set. Basically, they follow 80-20 ratio where they take 80% of data, right, from the data entries in the data set, and they use this 80% of data to train the algorithm, and they keep 20% of the data to test the model, that is output of the machine learning process, because this data set has the actual values, so that they can actually test the model on the rest 20% of data entries in the data set. Now, step 3, once they perform this isolation, that is once they split the data, now the important part is choosing an algorithm. This is very, very important because there are multiple algorithms. For example, the popular ones that data scientists usually use are logistic regression. This is one popular algorithm used by data scientists. Decision tree, even k-nearest neighbor. So these are some popular algorithms. In this case, for predicting a flower, I think decision tree is very good, and data scientists will go with this particular algorithm. Even logistic regression is also a very good algorithm for this problem statement. Now, this is not up to MLOps engineers. You don't have to actually understand which algorithm is the best, because this call is taken by the data scientists. Now, once these steps are done, the fourth step is to train the model. As I told you, model is trained on 80% of data with input features and the output. Now the model understands during the training process, okay, so if this is the petal length, this is the petal width, this is the sepal length, and this is the sepal width, this should be a rose. Similarly, model starts identifying the patterns. Very simple pattern can be, this can be a vague one, but a simple pattern that algorithm identifies is that maybe if sepal length and sepal width are small, it can be a rose. Or if sepal length and petal width are small, it can be a jasmine. This way, it starts developing some mathematical functions. As I told you, after a while, once it starts understanding the data and once it starts identifying the patterns, eventually it will develop a mathematical function, and that mathematical function is what we call as model. So model is basically the output of the training process. However, it is very important for the data scientist to test the model, because you might have a model, but it might not return accurate results. It can be because problem with your data set, or it can be problem with the algorithm that data scientist has chosen. In any case, the created model should always be tested. In case the performance of the model is not good, if it starts returning wrong results, then again the data scientist should work on retraining of the model. Maybe they have to change the data set, or maybe they have to change the algorithm so that results are accurate. Finally, step 7 is to package the model, right? Because end of the day, the model has to be saved or the model has to be packaged. And this is popularly done in .pkl format. Don't worry, we will learn these things practically as well. But before we get into the practicals, it is important to understand the theory part. So it is usually done in .pkl format, joblib format, or even in ONNX format. So these are the popular ones. Anyways, PKL and joblib are very often used. Now, once the model is saved, usually software developers or even ML engineers, they develop API for the model, or they try to package the model into a software applications so that models can be shipped. Or sometimes models are consumed by software applications so that the software applications can be deployed and made accessible to common people as part of a website, or maybe as part of a mobile application. So this is the usual process how data scientists create a model. As I told you, we will also learn these things in practical, but first of all, understand these are the 8 steps that are typically involved in creating a model. What is MLOps? MLOps stands for Machine Learning Operations. In simple words, MLOps is inspired by DevOps, or MLOps is DevOps for machine learning. To understand this better, let's go a step back and quickly revise what is DevOps. So DevOps is development plus operations. Or DevOps is set of best practices that unify development activities and operations activities so that organization can ship the application much safer, faster, and in the most reliable way. Let's take an example here. Imagine there is an organization that hasn't implemented DevOps. And this organization is working on building their website. So initially, the development team of the organization will start with developing the source code. Then they would build the application locally once they're comfortable. Then they'll test the application locally to ensure unit tests are passing and application is working as expected. Finally, they also interact with QA team to test the application even more thoroughly. A point to be noted, all of these activities are performed manually. Now, once this is done, development team interacts with the operations team. They share information of the application with the operations team. And this is where operations team comes into picture and they deploy the application to an environment. It can be lower environment or it can be production. But in this case, operations team also performs multiple activities. It can be setting up an application server, setting up load balancer, API gateway, SSL, containerizing the application, even shipping the application to Kubernetes. Everything a modern day application would need. And most of these activities are also manual. Now, this is a problem for the organization because performing so many activities manually would take a lot of time to build the website. Because usually applications are not built in the very first iteration. In this case, development team might not build the required website in the first iteration. They might take up to 10 iterations to build the required website. And for every iteration, development team would perform these activities manually. Then they would share the information with the operations team, and operations team also perform majority of these activities manually. Imagine how much time this would take for the organization. On the contrary, if the organization would have implemented DevOps, as I told you, DevOps is a set of best practices that can unify development operations or development activities and operations activities. So basically, DevOps can automate most of these activities and ship the application much faster for the organization. How? So the DevOps team follows some practices. For example, CI/CD is a practice where DevOps team builds a pipeline. Every time developer makes a change to the source code, all of these things are automated in the pipeline. So once the source code is changed, application is built automatically, tested automatically, even functional tests are executed automatically, and application is deployed to the target environment automatically. Everything happens through a pipeline that DevOps engineer has built. Along with that, DevOps engineers also automate infrastructure using infrastructure as code. They also take care of Kubernetes management. So DevOps significantly enhances software development lifecycle. Now looking at these advantages, looking at what DevOps has done to the traditional applications, MLOps came into picture. Because just like traditional applications, even building models and shipping models to production is a quite tedious activity. Let me explain this with an example as well. Imagine there is an organization that hasn't implemented MLOps. And this organization is working on building a model for recommendation engine. So let's say the organization is an OTT platform and they are building a model for recommendation engine. Now, in this case, initially the data scientist team along with ML engineers, they will start with working on collecting the data and preparing the data. Once that is done, data scientists will work on initial model development, model evaluation, and model validation. Once this is done, the ML engineers will work on developing API for the model so that model can be shipped along with software application. And they would also build the model and test the model locally. Now, once this is done, again, all of these activities are performed manually. Once this is done, the data scientist team and ML engineers will collaborate with operations team to ship the model to production. Again, in this case, operations team perform various activities. It can be setting up load balancer, setting up API gateway, containerizing the model, deploying the model to Kubernetes, even setting up CDN for the model. And these activities are also manual. Again, just like traditional applications, even models are not built in the very first iteration. The performance of the recommendation engine model might not be as expected in the very first iteration. So the data scientists and ML engineers might take up to 10 or even 20 iterations to get required efficiency of the model. And every time these activities are performed manually, and these activities are performed manually if MLOps is not implemented within the organization. Imagine how much time this would take for the organization. So that's why organizations today implement MLOps just like DevOps so that MLOps engineers can implement CI/CD, but for the models, so that every time there is a change that is made, these activities are automated in the pipeline, and these activities are also automated in the pipeline. MLOps engineers also implement infrastructure as code. They also implement observability and Kubernetes management. Even installing the required tools, setting up them, configuring automations that are required. So this way, MLOps can significantly enhance machine learning lifecycle. There is a simple difference. DevOps is for traditional software development lifecycle. MLOps, which is inspired by DevOps, is for machine learning lifecycle. or for machine learning models. Now, the big question is that a lot of people ask me this question, Abhishek, can DevOps and MLOps coexist in a company? Definitely yes. Let's see some examples. Imagine Netflix. I'm sure everyone understands Netflix. So Netflix, the engineers at Netflix work on developing their traditional applications. It can be as simple as implementing the payment gateway or payments microservice. Now this is a traditional application. So the development team works on development activities. Operations team works on deploying the payment. Instead, what Netflix does, they set up a DevOps team so that once the development team makes a change to the payments application, the payment service is automatically shipped to the production or at least to the lower environment. Now, the same Netflix as an organization, because it's an OTT platform and because it has viewers, they might want to set up a recommendation engine. Every time user logs in, Netflix should suggest them some recommended movies according to the user watch list, according to the geographical location of the user. So Netflix wants to build a recommendation engine, which is a machine learning model. Now, in this case, Netflix would set up MLOps team so that every time data scientists and ML engineers works on updating the model, MLOps can ship the model to production very, very fast. Same is with, we'll take another example. Imagine PayPal. Again, a very popular one. So at PayPal organization has traditional applications. It can be the user interface of PayPal, right? The login microservice. Now this microservice is dealt by DevOps teams. So every time development team makes changes to the UI, DevOps teams automatically deploy the UI to production or to an environment by automating various stages in the software development lifecycle. Similarly, PayPal as a company, they also need a fraud detection model. Imagine somebody using PayPal for fraudulent transactions. So PayPal might want to set up a fraud detection model to identify and catch such people. In this case, the data scientists and machine learning engineers will work on developing this model, and PayPal team or PayPal organization sets up a MLOps team so that they can ship this model to production at rapid pace by automating various stages that are involved in developing the fraud detection model or automating machine learning lifecycle. So this is how DevOps teams and MLOps teams can coexist in an organization. Understand this? MLOps is not a replacement to DevOps, but they are totally different. This is for traditional applications and this is for machine learning models. In the next lectures, we will understand more about machine learning lifecycle. What is a machine learning lifecycle? So machine learning lifecycle is a complete journey that involves building a model, deploying the model, and even monitoring the model once it is put in the production environment. In simple words, it covers everything right from collecting raw data to monitoring the model, as I told you, once it is in the production environment. To become an MLOps engineer, you should understand all the stages that are involved, and you should also understand how to automate operations that are involved in each stage of machine learning lifecycle. In this video, let's understand the stages as part of the course. As we move to next videos in the course, we will try to understand each stage in depth. So the first stage, if an organization wants to build their model, the first stage would be problem definition. This is exactly same as traditional software development as well. The first stage is always understanding the problem as detailed as possible. Now, once this is done, the second stage is data collection. Because end of the day, to train the models, you need data. So in this stage, data scientists gather the data from various sources. For example, if the organization wants to predict type of flower, they can go to a publicly available dataset, that is the IRIS dataset. Or let's say they want to solve a problem that does not have a dataset publicly available, then it is the responsibility of data scientists to gather data. It can be from databases, it can be from APIs, it can be from logs or any other data sources. Then the third stage, once the data is gathered, the next stage is cleaning of the data. Why? Because the data that is gathered, let's say data is gathered from logs and database. There can be some duplicates in the data. So that's why it is important to clean the data. Not only duplicates, there can be some wrong fields in the data, or some part of the data might be wrong. So you should remove that part, or there can be duplicates as I told you. So basically removing the noise as well as duplicates so that model returns accurate results once it is trained. Then the next one or the next stage is feature engineering. Let me explain this in very, very simple words. A lot of people get confused with feature engineering, but it is actually very simple. If we go back to our example of predicting a flower, imagine data scientists gather the data from IRIS dataset. Now this dataset has, for example, petal length, petal width, sepal length, and sepal width. These are the 4 features in the data. Of course, type of the flower. Now, if data scientists feel, or together with machine learning engineers, if they feel more features can be added to this so that model can be trained in a better way and model output can enhance. So the data scientists can add a new feature here, maybe something like petal length by sepal length. If they feel that this ratio can help the model, they will add a new feature to this data set. Similarly, if they feel the total area of the petals and sepals can help the models to predict type of flower better, then they can also add a new feature, which is total area or total length of the flower. So this way, in the feature engineering, data scientists add new features to the existing data set. Trust me, this is very, very important because a lot of times the data that you get from the publicly available sources or even from the database might not help the model as much, but with feature engineering, data takes a new shape. Then the next one is model selection. So when we say model selection, don't get confused here. In machine learning, models and algorithms are always interchangeable words. In this case, when we say model selection, it is mostly algorithm selection, right? So whenever you see model selection, you don't have to get confused that, okay, I'm actually building a model. What does model selection mean here? Usually models and algorithms are interchangeable words in machine learning process. As I told you, there are very popular algorithms such as linear regression, decision trees, random forest, neural networks, even logistic regression. So there are a lot of algorithms that are available. So it is the responsibility of the data scientist to identify the algorithm as per the requirement. And once this algorithm is identified, you all know the next step is model training, the most important stage. Because in this stage, algorithm is trained with the data set so that model will start identifying the patterns and model will start developing a mathematical function, which is basically the model, right? Or algorithm starts developing a mathematical function, which is basically the output model that you are looking for. Now the model training is done. As I told you, model training is usually done with 80% of the data set so that the rest 20% of the data can be used to evaluation of the model. Just to make sure your model is returning the accurate results. If the model does not return the accurate results, there will be an extension to this stage, which is model retraining. Now, then the next stage is hyperparameter tuning. For now, you can just leave this stage because this is slightly complex at this point of time. So I will talk more about it as we move forward in the next steps of this course. Then data scientists, machine learning engineers, they approach the operations team to deploy the model. Because till now, all these stages are typically about working with model development, model training on the local environments. But end of the day, this model, it can be Netflix recommendation engine, it can be PayPal's fraud detection engine, or it can be your hobby project or your college project to predict a type of flower. End of the day, these models have to be deployed. How these models will be deployed? We learned in the previous lecture as well. Usually models are packaged into software applications. It can be through APIs, it can be into mobile applications, or it can be into websites so that end users can actually use the model. Just like how you go to Netflix today and use their recommendation engine, which is a model. You are either using it through their mobile application or you are using it through their website. Now, finally, once all of these stages are done, it is up to model monitoring and model maintenance. You can consider them as different stages or you can consider them as the same stage. But it is very critical to monitor the model because end of the day, your model accuracy might go down as new data keeps coming in, new users keep coming in. Sometimes your model prediction might go down. So you have to monitor the model, and if the efficiency goes down, again, maybe you have to start with feature engineering. You might have to select a new algorithm, retrain the model, evaluate the model, hypertune, and deploy the new version of the model. That's why it is called as machine learning lifecycle. This is not a one-time activity, but these stages are performed in loop, just like software development lifecycle, right? Once you deploy a software application, you set up observability for the application. Whenever you see there are some issues with the application, there are some bugs reported, you go back, start developing the software application, features to it, fixes to it. Again, you build it, you deploy it, you test it. Same is with models as well. In fact, there are a lot of similarities between software development lifecycle and machine learning lifecycle. So what we will do throughout this course is we will focus on majority of these stages or all of these stages, identify what are operations that are involved, manual activities, and we will try to introduce MLOps practices to automate them. It is going to be very, very simple. By the end of this course, you will become a MLOps expert. So this is about machine learning lifecycle. Once again, just for quick revision, the first step is problem definition. Second stage is data collection, that is gathering of data. It can be publicly available data sets or creating a new data set through databases, APIs, logs, whatever is required from the data sources. Then cleaning of the data, because a lot of times data can be with noise, duplicate values. So data scientists clean the data. Then it comes to feature engineering, where new features can be added to the existing data set, such as total area of the flower or total length of the flower with the existing iris dataset. Then the algorithm selection, because there are very popular algorithms, data scientist has to pick one of the algorithm or they have to develop their own algorithm. Then training of the model, which is the most critical stage. Then evaluating the model. What is the performance? How accurate is your model? Is it 90%? Is it 95%? Is it 99%? You will understand that in the model evaluation stage. If that is not accurate, you will again train the model to enhance the efficiency. Then comes hyperparameter tuning. And finally, you deploy the model and monitor the model. These are the different stages of machine learning lifecycle. Now that we gained a fundamental understanding, let's go ahead and address the big elephant in the room. That is, what is the difference between data science, ML, and MLOps? To be honest, they are fundamentally very different, but a lot of people get confused with it. Using machine learning lifecycle, let's try to understand clear differences between them. We will start with data science role first. Let's say an organization wants to build their ML system or they want to build a model. Data scientists take the lead and they start with understanding the problem statement, or they start with understanding the business requirements. Once this is done, they go ahead and gather the required data. Now this can be some existing data sets or through some internal data sources like logs or from the database or any other internal sources. Once they gather the data, they also work on cleaning the data. That is basically removing the noise from the data, removing duplicates from the data so that the data is good for training. Data scientists at times also work on feature engineering by adding new features to the existing data set. It is also responsibility of the data scientist to decide a model or to decide an algorithm. From a lot of algorithms that are available out there, data scientists decide which algorithm fits the problem statement the best. And then data scientists work on training the model and evaluating the model by choosing 20% of the data from the dataset or maybe 30% data from the dataset. So all of these activities are actually taken care by the data scientists. Now, once data scientists are done with building the model and evaluating the model on the local systems, this is where ML engineers come into picture. The responsibility of the ML engineers is to take the model from the data scientists and convert the model to production ready state. That can be to optimize the model for performance, optimize the model for scalability. Some factors like latency, throughput, memory, basically to convert it to production ready state. And then ML engineers also work on developing APIs for this model. End of the day, models are shipped as software applications or packages. So it is also responsibility of ML engineers to ship this application or integrate this into the backend systems. It can be to their mobile applications, websites, or maybe to their regular applications. I'll give an example here. Imagine Netflix planning to build their recommendation system and they want to build one of their models. So data scientists, as I told you, they work on understanding the problem statement, collecting the data, cleaning the data, feature engineering, model selection, model training, and they also evaluate the model. Once data scientists at Netflix feel they are good with the model, they hand over the model to the ML engineers where ML engineers at Netflix, they update the code to make it production ready. They develop APIs for it so that the model can be integrated to the Netflix backend system, so that end users can access this model through Netflix mobile application, through Netflix website application, or any other thing that Netflix supports. So this is where ML engineers comes into picture. Now, once this is done, once the model is production ready, if you take some startups today, they ask ML engineers to also deploy the model and to monitor the model in the production, which is a bad practice, but startups do it today. Now, when you look at enterprises or MNCs, they have some operations team. And this operations team is responsible for deploying the model and maintaining the model. Then where does MLOps comes into picture? This is very, very important. So the responsibility of the MLOps engineer, as I told you, is to introduce the practices, right? And through these practices, MLOps engineers identifies the gaps or manual activities in the machine learning lifecycle. They talk to data scientists, understand the manual efforts in their day-to-day work. They talk to ML engineers, understand manual activities in their day-to-day operations, and even they try to automate the operations effort. Let's try to understand this with some examples. What are some day-to-day activities of MLOps engineers? They work with data scientists to build reproducible training pipelines. Now, if you look at machine learning lifecycle, training the model is a continuous process. If the model performance is not good, then the data scientists have to work on feature engineering and they have to retrain the model, or they have to work on algorithm and retrain the model. Maybe they want to do it 10 times a day or 20 times a day. Every time if they do it manually, it takes a lot of time. So MLOps engineers help data scientists by building automated training pipelines or reproducible training pipelines. You can call it as CT pipelines. Or if you take example of deploying the model. So MLOps engineers help the operations team, or maybe they take the operations work completely. They hand over that task by automating through continuous deployment. So every time ML engineers are ready with the models, MLOps engineers introduce the CI/CD process so that model is deployed to the production environment. They can also automate the observability setup. Similarly, MLOps engineers work on setting up the model registry where models are saved. Just like if you take example of software applications, today they are stored in JFrog or they are stored in Docker registries. Similarly, MLOps engineers set up and configure model registries. They also help with setting up the infrastructure. If you look at this entire thing, everything is taken care in the local environments, but end of the day, you want to deploy the model in production. You want a staging environment for your model. You want a development environment for your model, for which you need infrastructure. MLOps engineers work on setting up infrastructure through infrastructure as code practices. It can be something like Terraform. Observability is also a critical role because model performance usually goes down. So MLOps engineers configure some alerts, they send some notifications. Finally, MLOps engineers' responsibility is also to work on setting up things like Kubernetes, setting up GPU-based Kubernetes instances, scaling Kubernetes, and ensuring the cost optimization for the organization. All of this is taken care by MLOps engineers. In very simple words, MLOps engineers enable data scientists and ML engineers to ship the model faster and safer. So this is the difference between data science, ML, and MLOps. I hope it is clear to you. All right.